Algebra 3 modulus, type 3 modulus graphs. So far we've seen that when we have the symbols with the two lines, that we know that this means that we have to take the absolute value, in other words, the positive value of the function. So in this section, what we're going to look at is, well, what does that mean if we actually draw the graph? What does a modulus graph actually look like? What is its characteristic shape? So in this example here, we are asked to graph two modulus functions. First one is f of x equals 3x plus 5. The second one is h of x is equal to x minus 1. And the question says, hence, find the values for x, where f of x equals h of x is less than h of x, and f of x is greater than or equal to h of x. So it's always important to note this word hence in a question. So when it says hence in the question, that means we have to use the answers from the previous part of the question. So basically that means if we've drawn the graph, then we have to use our graph to find the answers for part 1, part 2 and part 3. Now the only problem with this question here is that we're not given a domain. We don't know what we're plotting our graph in terms of from what on the x-axis. So the easiest thing to do with these modulus graphs is figure out where are both of these functions going to cut the x-axis. And if we know where they cut the x-axis, well, that means that we're going to let y equal to 0, and then we'll take a point to the left and the right of that point. So once we've let y equal 0 and we get our point, what we want to do then is choose a point to the left and right of that point. And that's going to give us the characteristic shape. So the graph is basically going to be a V shape. And when we make out our table, we'll see why in a minute. Okay, so let's take the first one, which is f of x. So if I let f of x equal 0, in other words, we're letting y equal 0, well, that gives me 3x plus 5 equals 0. So in other words, 3x plus 5 must equal 0. So x equals minus 5 over 3. Now, it's always hard to plot a fraction, so it's easier to write that as a decimal. So that's minus 1.67 approximately. And then I will choose a point to the left and to the right of this number. Okay, so again, it doesn't matter what point I choose to the left or the right, but I'm not going to go straight next to minus 1.67 and choose minus 2. I might just move a little bit further left. So I'm going to go with minus 4. And then I'll go on the positive sense of the x-axis as well. So I'll go plus 4. But I could have chosen minus 3 and 1, or I could choose minus 5 and 4. It doesn't matter what we do. If we sketch the graph and we don't get the shape we're looking for, we can just extend the graph. So let's sub in the values. So it's 3 times minus 4 plus 5. But again, it's inside our modulus signs. So inside the modulus signs there, we can see we have 3 times minus 4, which is minus 12. Minus 12 plus 5 is minus 7. So if I just star that for a minute, if I bring that down to the bottom there, that's the answer, minus 7 inside the modulus signs. But we remember at the start of the video I said that that means that we take the absolute value, which is the plus value, which is 7. So therefore my coordinate is out to minus 4 and up to 7. If I sub in 4, well, that gives me 3 times 4 plus 5. So this time we get 12 plus 5, which is 17. So that means I'm going out to 4 and up to 17. So now I have 3 points for my graph. I have where it cuts the x-axis, which is minus 1.67 and 0. And then I have my 2 points to the left and the right of that value. We're going to repeat that for the second graph, which was h of x. So we had h of x was the modulus of x minus 1. So again, we start by letting h of x equal 0. So in other words, we're letting y equal 0. And if I do that, that gives me x minus 1 equals 0. So if x minus 1 equals 0, that means that x equals 1. So my point is out to 1 and up to 0. So again, I can choose any points I want to the left and the right of this point. So I don't have to choose the same x values as I did for f of x, but sometimes it makes sense to choose the same because then when we sketch them on the same axis, we have them within the same range. So I'm going to stick with minus 4 and 4. But again, I could have chosen minus 1 and I could have chosen 2. but we might find then that the two graphs don't overlap properly, so we would have to extend them anyway. So if I sub in, we get -4 minus 1. So again, if I star that and just go down to the bottom of the table there, that means that we end up with -5 inside the modulus sign. So that means we take the absolute value, which is 5, and therefore that gives me a coordinate -4, 5. And if I sub in for 4, well, we get 4 minus 1, which is 3. So that means I go out to 4 and up to 3. So now I have 3 points for both of my graphs. Okay, so if we plot our 3 points, we had out to -1.67 and up to 0. So that's where the graph is cutting the x-axis. We have out to -4, 7, and we had out to 4, 17. And if we join -4, 7 to where it touches the x-axis, and then we join -1.670 to 417, you see that we actually get 2 straight lines. So again, if we think about what f of x was, it was 3x plus 5, which is linear. So inside the modulus there, what we would have is that we can only ever get a positive output. So if we can only ever get a positive output, that means that the y values are always positive, which means that the graph is always above the x-axis. So therefore, if we were to plot x minus 1, then we will also find that the graph will be above the x-axis, because again, the outputs will always be positive. So again, we can see with h of x, it is again above the x-axis. And again, you can see clearly here that I've labelled f of x and h of x. So if you don't have a different colour, just please make sure that you are distinguishing between the two graphs. You should always label your two graphs, and then having them in a different colour helps it to answer the second part of the question. So we can see that the graphs overlap, and they overlap at 2 points. So if I mark where they meet, we call those the points of intersection. So basically, the points of intersection means that that's where the graphs are equal. So in other words, that's where f of x equals h of x, which is the first part of the question that we have to answer. So if I mark my values in, I can see that if I go down from the point of intersection to the x-axis, then my x values are x equals -3 and x equals -1. So in other words, they are the two x values that make the graphs be equal. So in other words, f of x equals h of x when x equals -3 and when x equals -1. Now if we're asked for the points of intersection, we would have to give the y value as well, which is -3, 4 and -1, 2. So for the second part of the question, it says, well, where is f of x less than h of x? So basically, what does that mean? Well, that means, where does the graph f of x lie below h of x? So if we look at the graph, f of x is our green graph and h of x is our blue graph. So basically we're looking for where is the green graph below the blue graph. And if I look, I can see here the green is below from there. So that means it's basically lying below the blue graph between the values of -3 and -1. So therefore we write that as -3 is less than x, which is less than -1. So in other words, when the input is somewhere between -3 and -1, the green graph f of x will always be beneath the blue graph h of x. So the last part of the graph then says, well, where is f of x greater than or equal to h of x? So again, that means we're looking for where is the green graph lying above the blue graph. So again, if I look, where is my green graph above the blue graph? Well, I can see if I read from left to right that all of those values there are above. And again, all of these values here are above the blue graph. So that basically means that if I go to the left of the graph from -3. And if I go to the right of the graph from -1, then the green graph, f of x, is always going to be above the blue graph, because you can see the two lines are diverging away from each other. So they're never ever going to intersect again. So therefore we write our answer as f of x is greater than or equal to h of x when x is less than or equal to -3, or when x is greater than or equal to -1. So basically, for all linear modulus equations, when we draw them, they're always going to be a V shape above the x-axis. It would only be the reverse if we had a negative sign in front of one of these modulus. So if we had minus outside the modulus sign, then what would happen is the graph would flip upside down. But we're going to see that later on when we're doing the chapter on functions. So if we go to our Active Maths Book 1 and we go to page 79 and we do question 11, 18 and 21.